Okay, so question 11. It's a probability tree diagram about whether Peter is late or on time to work depending on whether he's walked or cycled. So the first thing we do is this diagram is missing some information that we should fill in, and that is the actual probabilities on this right hand side. So we want to work out the probability that he walks and is late, walks and is on time, walks, cycles and is late, cycles and on time. And that's really quite straightforward. It's 0.25 times 0.1, which is 0.025. Then we're going to do 0.25 times 0.9. I'll just use the calculator. 0.25, whoops. 0.25 times 0.9, and that's 0.225. He's late, so that's going to be 0.75 times 0.05. 0.75 times 0.05 equals 0.0375. And then 0.75 times 0.95 is this. So 0.75 times 0.95 is equal to 0.7125. And so we do all this here, and that then means that we've got all the multiplication dealt with, and all we have to really worry about is division or a few things like that. So let's go and read the rest of the question and answer that now. On a day chosen at random, Peter walked to work. Okay, so write down the probability that he was on time. So he's walking to work, so the probability that he's going to be on time is 0.9. Really nice and easy. Trick question. It didn't say what is the probability that he walked to work. It says he chosen at random, he walks to work. So from that, what is the probability? So it's 0.9. So find the probability that Peter cycled to work and was late. So really, this is what we're working out. This is the probability that he cycle and is given by intersection late. So we go in here and we find that he cycles and is late, and that's the branch that we're following there. So the answer that we're looking for is this one. Okay, that's our branch there. Okay, so that's actually our answer, 0.0375. So 0.0375. Okay, so let's go on to C now. The probability that given Peter was late, he cycled to work. Well, this has really been written backwards. It's not a nice way to write it. It really should have been find the probability that he cycled to work given Peter was late, or given that he was late. So if we write this down, so this would be cycle given that he was late. And this is actually a formula, and it's in our formula booklet. If we go and have a look here in topic 3, in 3.7, conditional probability, A given B. So on the top, we're going to have the probability of cycle and late, and underneath the probability of late. Okay, so the probability of cycle and late is 0.0375, and probability of being late, so basically the ones of being late are this one up here, this one here, and this one here that we actually already dealt with. So we want to add these two together. So the probability of late is equal to 0.025 plus 0.0375. So let's add them together. 0.025 plus 0.0375. And that is what we've got there. 0.0625. Now if we just divide these two, 0.0375 divided by 0.0625, we should get an answer of 0.6. So that is the probability that given Peter was late, he cycled to work, 0.6.